end. Today, we're going to discuss a complete digital workflow to engineer immediate prototypes for full mouth rehabilitation. And we want to first give a little context of why, we feel like we are leading the way in full mouth rehabilitation. And then we want to lay out the step-by-step clinical workflow, techno-clinical workflow to achieve these high-level complex prosthodontic projects. Again, my name is Nick. I work for Zirkonzahn, and Zirkonzahn is a company that is based out of the Italian Alps. It's a German-speaking region of northern Italy where we have a lot of people that tend to work very diligent lives with their hands, artisans, craftsmen, with a penchant for handcraft, a penchant for quality. And South Tyrol is the homeland of our founder, Mr. Enrico Steger, who in 2003, from what I understand, was at a flea market and saw a device that was used to enlarge a painting. And he realized that we could use this same type of technology to copy mill our structures in zirconia material. For at the time, we had an issue with metal-based frameworks where we were not able to have enough light that would mimic the natural tooth aesthetic come through our metal-based frameworks. And so we realized that there would be a future in zirconia, as it is a material that absorbs just the right amount of light to imitate natural tooth aesthetics. And at the time, we were having to send tactile scans out to offsite manufacturing plants to receive a coping that may or may not fit on the Geller model. And so our idea was that if we build a wax up by hand on our own and we trace this wax up with a stylus parallel to what we're tracing, we could copy mill our wax ups in zirconia. And with that idea, we brought the original manual milling machine to empower laboratories and clinics with in-house zirconia milling technology. But the Zircograph, the original manual milling machine, was not born without its challenges. See, when we go to place zirconia into a sintering furnace, zirconia will shrink more or less 20%. And from manufacturer to manufacturer, from batch to batch, from lot to lot, these shrink rate properties may vary. And so we needed to make a zirconia that was going to have a constant shrink rate so that we could guarantee working results. And this established our founding pillar at Zirkonzahn to build a comprehensive ecosystem under one roof to guarantee your working results, from the manual milling machine to the zirconia to the color liquids, all the way down to the tungsten carbide burrs we use at the bench to elaborate our green state structures. And just a few years after bringing this device to the market, we led the digital revolution with desktop scanning appliances and 5-axis milling machines of all shapes and sizes, some small, compact, wet and dry only units, or large scale production units. We are to process and design virtually any type of reconstruction, and we are also providing the final materials which we will mill our works of art in, such as high strength zirconia materials, high translucent zirconia materials, resin materials such as PEEK, PMMA, polycarbonate, model-based materials, all the way from wax to metal-based materials such as titanium and chrome cobalt. And we put all of these elements together in our world-renowned education centers that are imbued with the philosophy of life so that we can remember and realize our passion for dentistry. So it is very possible that as we're bringing all of these elements, the scanner, the design station, the milling machine, the materials together, we might also engage in extracurricular activities together, such as cooking a meal together, to build a feeling of passion that we get when we work together in a very organized and structured manner towards a common goal that brings us a satisfaction. And we will breathe this philosophy in these beautiful training centers around the world and take this philosophy to our new workbench, where we will assemble a technical project, design virtually any type of restorative appliance, perhaps guide our surgeries from a restorative point of view, take all of these components through a CAM solution, and breathe life and beauty into our milled restorations. Whether we are going to build full monolithic structures, reduce frameworks with individual primary structures, or telescopic appliances. And our mission has largely been centered around full mouth prosthetics, as we were the company that brought the first full arch monolithic zirconia bridge to the market. And that's why our history with the Zirkograph is so important, as we realized that this could be a very beautiful solution for full prosthetics. And our mission has always been to find innovative techniques to simplify full mouth restorative and surgical planning. About 6 years ago, we brought to market a new innovation that would simplify this complete process, and that is with the Face Hunter and the Plane system, which give us the opportunity to transfer the patient maxilla into a virtual articulator by means of 3D facial scans. And this is going to be the starting point of our technical project to engineer full mouth prototypes, which brings us now to the techno-clinical portion of this lecture, called Engineering a Prototype, where we will discuss how we are going to, with digital solutions, prefabricate a full mouth rehabilitation for a patient. And the first part of this process is all about establishing the technical project. And so we have a specific amount of data we will need to capture on the front end to set up a technical project that puts us in the condition where we can eliminate transmission errors by making more accurate functional and aesthetic assessments on the front end. And so we're going to gather digital impressions by means of intraoral scans. These digital impressions can be processed through CAD/CAM technology, and we can either print or mill these digital impressions to have a physical record. If this isn't an option, certainly we can take alginate impressions and pour a stone model. We'll also need CT scans of the patient, which we can export in our system into an STL file, very important step. We'll need some extraoral photos of the patient situation to start to understand some of the aesthetic motifs at play. Here, certainly, we can start to assess that the patient's lip line appears to be receding as her partial removable denture is canted. The laterals are rather monolithic, and the canines are not very sharp. So we can already imagine that we have some malfunction at play, that we don't have a canine guided occlusal scheme, which is something that we find is very important for fixed rehabilitation. So this is already an assessment of what we can do to balance out the patient's smile. We will also need intraoral recordings, which we glean through the Plane system, intraoral recordings of the maxillary position, which we will capture through the Plane system. And this is then coupled with 3D facial scans that we will gather with the device called Face Hunter. And all of this data is collected in the clinic. And if you're a laboratory, I highly recommend that we make ourselves present in the clinic to capture all of this information so that we can take that impression back home and prepare the case for our clinicians. This is a great service that we can provide, not only so that we can work with as many references as possible, but also so that we can take that burden off of our clinicians and thereby drive the treatment plan from the restorative perspective. And I imagine from the clinical side, if you're a clinician looking at this technology, you're probably gathering 90% of the records that we have put up on the screen, with the brief exception of the 3D facial scans. And we would like to demonstrate how this very, very simple 5 to 10 minute procedure with the patient will revolutionize the treatment care outcome by giving us more accurate and predictable prototyping results, which will eliminate transmission errors and exceed patient expectations while reducing the amount of time we spend at the chair and at the lab bench. And this is all going to be predicated on a device or on a system called Plane System, which at its center focuses on the plane finder, which has the very simple objective of registering the patient in a natural head position or along a 0 degree horizontal plane so that we can capture the patient's absolute midline as well as their allotragus plane left and right as it relates to a 0 degree horizontal plane. And as we know, just like the camper plane, allotragus is running parallel to patient occlusion, but it's an epidermal reference, and it's a reference that we could identify on a 3D facial scan. So in short, we are capturing the patient's individual occlusal plane through the allotragus, through the natural head position, just by having the patient walk into this device called Plane Finder and adopting that natural head position. Now, in a practical sense, it's very easy to incorporate this into the pre-op diagnostic consultation. We will simply request that the patient walks into the Plane Finder device, establishes their posture by placing one hand on each side of the Plane Finder, and they will look straight on into their eyes in the mirror. And they will thereby establish what Dr. Henry Maurice deems as the natural head position. This is a standardized position of the head with the patient in an upright posture, eyes focused to a point at the distance at eye level. And this came to dentistry not from Zirkonzahn, but from Dr. Henry Maurice, who is working out of Harvard University in the late 1950s and used this for his orthodontic treatment planning. And he took this from a Frankfurt meeting out of the late 1800s. So this reference plane, the natural head position, has been around for a very long time, and we now introduce this into our unique digital face bone transfer system. Now, one very important element within this natural head position is not only are we establishing a standardized position of the head, we also are establishing a reproducible position of the head, which is very, very critical in terms of giving us an accurate and predictable transfer of the maxilla. And what we will simply do to understand the predictability of this position is we will take a marker and we will place either a line or two dots alongside that 0 degree horizontal window that's running along the profile of my patient here. And we will then have the patient walk away from the Plane Finder device and then resume the position to check and see if those marks are consistently falling within the metal bar. And if we find that the patient is reproducibly assuming the same natural head position, we will simply take a 3D facial scan of the patient in natural head position to affix the natural head position as the point zero within our virtual plaster room, the Zirkonzahn scan software. From here, we will take a series of additional scans, such as the portrait, the profile left, the profile right, and a smiling image. Now, if you're an aesthetic maniac like we are, perhaps you're going to also capture the resting lip position, the letter S, the letter A, the letter F, mouth wide open, whatever we need. And these static and individual 3D facial scans are then merged together to create what is now a dynamic 3D virtual patient. And from here, I have all of the data required to transfer my maxilla into a virtual articulator by means of 3D face scanning. And simply in the cast mounting feature of our Zirkonzahn scan software, which I personally see as a virtual plaster room, we will be instructed to mark the skeletal midline, the masticatory center, which is the center fossa of my first molar, or 24 millimeters from the hamular notch if the patient is edentulous. And finally, we will mark the allotragus left and right. And if we just have a little bit of imagination here and consider, were the patient facing down or facing up, this angle that I have drawn would then increase or decrease in intensity with respect to the 0-degree horizontal plane. And this is a really nice image to bring home this point that the natural head position is absolutely fundamental to understanding the true inclination of the z-axis pitch of my maxilla within the articulator through this phase bow transfer system. And with that, these four reference planes, allotragus left, allotragus right, the masticatory center, and the skeletal midline, we have transferred our maxilla into a virtual articulator by means of 3D facial scanning. From here, we will bring the lower into position according to the bite that we have clinically recorded. And that's up to you, whether you're going to take that in centric occlusion or whether we need to create a new bite relationship through a central relation recording, whether you do that through a Lucia jig, some sort of equalizing appliance, or the bimanual positioning of Dawson. It doesn't matter. Your preference, we simply need the bite recording from the beginning. This is the preferred way of working. And what's missing here are the 3D facial scans. Is we have to imagine that these scans are floating somewhere in my virtual design station. And we need a mechanism to align the 3D facial scans to these mounted models. And from here, we will take simply a scan of the patient wearing a device called the face transfer fork. And the face transfer fork, again, is not transferring the maxilla into position. It is aligning my 3D facial scans to the mounted models like so. The patient is instructed to bite into some quick setting registration material. We took a 3D facial scan of the patient wearing the face transfer fork, and then with an intraoral scanner or a desktop scanner, we go to scan the face transfer fork and are instantly prompted to match the virtual maxilla to the impression left on the face transfer fork. And this then creates the alignment of my 3D facial scans to the mounted models. And this is an absolute dream to work with. We have models that were transferred one-to-one into a virtual articulator. This is the PS1 articulator shown on your screen. It is built from principles coming from Alfred Giese, where we've shifted the axis of rotation to the mastoid process to get a more natural arc of opening to eliminate retrusive movements. That being said, we can also integrate this same exact process with a number of different articulators that you can find inside the Zirkonzahn scan software. And I believe that we're pushing about 20, 25 different options there. And this is an absolute dream to work with, as I have all of my references properly mounted in alignment with the 3D facial scan, so I can make a very quick functional and aesthetic analysis in the pre-op phase. But one thing that never ceases to amaze me is some of the history that comes with digital dentistry. And if you asked maybe 5-6 years ago, how could we transfer mounted models into a virtual articulator? The answer was we needed to physically mount them and scan the mounted models in a desktop scanner. But today we have demonstrated a workflow where we took digital information, 100% digital information, to create this relationship inside the articulator. And we certainly now need a mechanism to take my digital mount and transfer that into a physical articulator. And of course, we have a solution for that. We will call upon a universal mounting table called Plane Positioner inside of my virtual scan software. And we will then load on the plane positioner what's called jaw positioner. This is the green plastic plate that you see loaded onto the plane positioner. We go to increase the table height to actually have that jaw positioner intersect with our maxillary position. And through this intersection, we create now a impression in the jaw positioner, which is then milled into the physical jaw positioner. It's placed onto our physical mounting table, and it receives our milled, printed, or poured maxilla. We will then fix this with plaster and introduce the lower jaw according to the bite that we've recorded. And at this point, we have established the technical project, and we can go into the digital prototyping phase where, let's say, for an example, we have a patient like this who has some severe abrasions, they're overclosed, they're missing teeth, there is some aesthetic work to be done to restore confidence, and more importantly, there's some functional work to be done to restore the apparatus that is this person's intermaxillary position. And we will then go to then capture a new bite relationship through a centric relation recording, however you want to do that. We take the impression here. You can already see through this impression, we really are going to restore some of her profile. We're going to support her lips a little bit more, and we're going to restore function as well as aesthetics. And we go to introduce all of the data that we just showed you, the 3D facial scans, the models. We mount them together, and we will design a brand new occlusal scheme for this patient, which we can test out on a virtual articulator. And this new occlusal scheme will first be milled in the form of an anatomic bite splint, a non-invasive appliance that can be milled as thin as 3/10 of a millimeter and is milled in a material called multistratum flexible. This is a very, very nice resin material with just the right amount of durability, amazing translucency, and a seamless shade gradation. And we can simply snap this appliance over the patient's existing dentition. And we are here achieving three things. Well, if four things really. The laboratory is providing a service for their clinicians where we are using this tool to assess patient function with a non-invasive therapy. Secondly, we're going to assess patient aesthetics. Thirdly, we're going to make the patient comfortable with the treatment that we can provide them in terms of easing them towards a more invasive type of solution, such as an all-on form. And certainly, if a laboratory is providing this service, then they are using or helping the doctor create a case acceptance workflow within their practice. So the laboratory-driven protocol is helping the patient choose to go forward with the invasive solution. And certainly when the patient will wear this prototype, this non-invasive prototype, for a matter of weeks, they will inherently add their own individual occlusal abrasions into the prototype, and we can take those individual occlusal abrasions, which are worth their weight in gold, and we can rescan the appliance and introduce that back into our workflow so that we can then adapt the new and patient-specific occlusal scheme to our invasive prototype. And that will look like this. So we are assessing function and aesthetics. The laboratory is driving a service for their clinicians to improve on case acceptance protocols, and we can take the patient-specific functional recordings back into the workflow and imprint them on our invasive prototype. So once the patient has worn this appliance for some time, now we go to rescan everything and we bring it back into our workflow. By the way, this is a totally different patient, but just follow the logic. Here we can certainly merge the CT scans of the patient to my situation models. These CT scans can be modified to my needs and necessities, but what is absolutely amazing is that I will never lose sight of my references. I can toggle back and forth between seeing the situation and seeing my working model, my dimension and my vertical dimension that I can work within. And of course, we have the 3D facial scans. Now, before we go forward and we perform a virtual setup, There's one final element that we can introduce into our workflow, and that is tried and true reference objects such as the Monson Sphere, which we know to be round about 8 inches in diameter. It's a geometrical sphere that will intersect with the eminence and captures the curve of Spee and curve of Wilson in my mandibular restoration. And we can go in the virtual design station to place this reference object, and we can see it in relation to my situation object. So I can see that if I want to respect the pitch of my central mandibular incisors, I might need to build some vertical dimension. But in the posterior region, more or less, the buccal and lingual cuffs are touching the Monson Sphere. And so this is a great, great tool to understand how we can functionally rehabilitate this patient. And it gives us a template for making a very easy and simple tooth setup. We simply follow the sphere and ensure that the buccal and lingual cuffs are touching the Monson Sphere. We go to then, of course, see everything from 360 degrees, draw some virtual gingiva, save this out, and we go now with the upper, this time with the 3D facial scans captured by the Face Hunter, as well as a reference table such as the golden proportion table, which is split left and right for the deviation in the patient's individual occlusal plane left and right. And we again have a very easy template to follow. So very quickly in this design station, we can create a functional and aesthetic setup just because we started from the very beginning by capturing as much information as we could possibly have. And this is made very simple because we just have to put everything together with a couple of files. And here we go to follow the golden proportion table and we place our teeth. And this is not just a simple PDF editor. This is not a 2D image where we don't know really where that lip line is falling or what the restoration will look like from the profile view. We can see everything to scale in 3 dimensions, and we understand that really, wow, what does this light between, or sorry, what does this triangle between the lateral and canine do to allow light into the smile? What happens when I have this little point on the lateral? Suddenly on this lateral incisal edge, we've added the tiniest little aesthetic finesse. What happens if I shift the laterals back or I open the central incisors to give them a butterfly effect? We can get an instant feedback to the aesthetic position of these teeth, because remember, especially in the US market, it's not about what shade we're going to provide on these full mouth rehabilitations. The aesthetic game comes to play when we're talking about not only the position, but also the morphology. And so if we forewent the first step of the anatomic bite splint, we could certainly show a patient side by side what they have versus where they are going. We can say, dear patient, this is what you look like with softer, rounder edges from the AIDA natural tooth library. This is why you need to have very pointy canines. This is what we can do to play with the aesthetics. See what happens when I bring those laterals back just a little bit. Or, dear patient, you belong to an older demographic, and so for us to give you a more natural looking restoration, we need to use a tooth library that has flatter, sharper edges. And all of these options are available to us with just the simple click of a button, and we can visualize them with a photorealistic tooth shade, for an example, the bleach shades or the Vita shades. And now we get to a point where we can really marvel at all the information we have available at our fingertips. We have the 3D facial scans combined with the DICOM data mounted on a virtual articulator to give me the proper relation of my virtual tooth setup. And this is the first time that I've ever seen something like this on a screen, where I am no longer using my thumb to wonder where the lip line is going to fall. I know exactly where my aesthetic midline is, and all of this was designed on a virtual articulator that is completely adjustable, so I can engineer a patient-specific function before proceeding with my invasive therapy. And now we get to the key question is, how are we going to bring this structure into the patient's mouth on the day of surgery? How is this going to be possible? Well, there are many techniques, certainly. We do have to understand as technicians that our doctors tend to have certain preferences. Now, some clinicians may prefer to freehand their same day immediate load. They may prefer to freehand the implant placement, do an osteectomy, freehand the implant placement. And for this, from a very, without a lot of work, we can simply take this pre-op virtual setup and mill it as a denture. And the surgeon will go to convert that denture over the implant sites to retrofit that denture. Now, I believe that digital technology, CAD/CAM, has given us the opportunity to get away from all of the problems that come when we take a denture and we convert it on the day of the surgery. It's a very time-consuming process. We often make functional mistakes, aesthetic mistakes, and at the end of the day, you might end up with a very unstable structure. So at a minimum, I believe we should leverage CAD/CAM technology to at least view our pre-op prototype, our blueprint, our technical drawing. We must view this technical drawing in combination with our DICOM data. And the technical and restorative team must have a conversation with the surgical team and ask, Doc, more or less, where are you going to place your implants? Because you might notice in the bottom right-hand corner here, we actually eliminated a premolar because no longer are we paid as technicians on how many teeth we can fit in the mouth. Now we are paid by the service that we can offer our doctors through this technology. And just by having that conversation with the surgical team, our technical team understood that, well, if an implant is going to be placed in what is now the center fossa of that first molar, well, that was once interproximal space between a premolar and a molar. So that's an unstable point for an implant in relation to my structure. And secondly, we were creating a cantilever that we were not comfortable with. And so we simply go to eliminate a tooth, and just by using this technology, we could make that decision. Otherwise, we would not have known that was going to be a problem. And certainly we could take it a little step further by taking an extra wide cylinder tool and stamping out large windows into my denture so I can do a conversion that's a little bit more easier. Or we can take it even a further step and start to guide the surgery with the Zirkonzahn implant planner software. And we can then, from a restorative point of view, place the implants into the proper position where we can see the relative bone density, and we can understand that we are creating stability for our structure. So we are restoratively driving the surgery. And the technical team can very easily, with the collaboration of our oral surgeons, provide almost like a smile in a box where we can take this file, this STL file, mill it in the form of a surgical guide next to our milled prototype. And we introduce the surgical guide into the mouth on the day of surgery. And yes, maybe we might have to widen or place the implant a little bit in a different position. It's not always 100% going in that position, but we are much better in terms of our denture conversions. We just have to widen a screw channel to get the passive fit that we need over that implant site. We don't have to go and use all of these acrylic masses to cure everything together and have ultimately a weak structure. We are 95% of the way there in terms of our denture conversion. And this is an amazing solution for laboratories that are providing a lot of full arch chairside services. It is a way of taking control of the case from a restorative point of view so that we can prioritize the occlusion, the function, and the aesthetics. And this is just a piece of plastic. It's a very simple PMMA prototype, but it is a work of art because a lot of thought has gone into how this structure is supposed to function on the day or in the patient's mouth, and how are we going to introduce this structure on the day of surgery. But I do understand that really so far we have put a lot of emphasis on the guided surgical protocols. And I have personally met thousands of surgeons across the United States, and I've shown them this workflow. And I do understand that many surgeons do not want to use the surgical guide, but they love this idea of engineering a prototype from the beginning that's going to have the right function, aesthetics, and stability. And we have to find a way to also help those types of surgeons with their work. And a lot of times this means that we have to post fabricate our immediate provisional. And if we want to post fabricate the immediate provisional, this sometimes used to mean that we would have to mill the entire structure overnight. And so no longer are we offering teeth today, but instead we're offering teeth tomorrow. And some clinicians might say, well, I don't want to touch the implants after they've been placed. I don't want to touch them the day after they were placed. I have to either load the structure today or just give them a denture and go home with the custom healing abutments. And so we have created a very special and unique solution for the surgeons that want to freehand their implant placement, and it is called double milling. This is a new digital denture conversion. We will go to work up the patient as we've always done before. We will simply then mill or nest only the occlusal half of the restoration, 80% of the restoration. This will get milled and it looks like this. And we are simply waiting to receive the post-op verified implant model, which we will then merge to this half milled structure. Now, we have a problem, is that my post-op model looks nothing like my pre-op model. And I need to cross-mount my post-op model to this pre-op model, as this pre-op model is the foundation of my half-milled structure. So on the day of the surgery, we go to introduce a palatal reference plate, and we will use this palatal reference as the link to cross-mount the pre-op model to my post-op model, and we can even go to use some photogrammetry if we want to be extra sophisticated with the implant precision and positions, and we merge those data points to our post-op tissue model, and in the matter of minutes, we have a verified implant model created digitally. This will then be merged, of course, or is already in position with my post-op, or sorry, my half-milled structure. I now have the implant positions, the screw channels, the platforms, and the intaglio, and I mill this within 45 minutes after the surgery. And I have an impeccable restoration that fits perfectly over the implant positions, which we can provide our patients on the day of the surgery if we are close by with the milling machine. So once we have the structure brought into the mouth, however we want to do that, whether we want to do the denture conversion, the guided surgery, we want to mill the structure for the next day or do double milling, it doesn't matter. Before we go to the final, we will do one last aesthetic try-in so that we can see the best option of the restoration before we mill in the final material. And this aesthetic try-in is performed 3 to 6 months after the implants have osseointegrated and the tissue is recessed. We go to bring the structure back into position, and we can already see that we made a mistake, that we have missed the midline by a few millimeters. And so now we want to go to correct that and to also see some different aesthetic solutions in terms of form and position. We go with the brush tool to reduce our wax up, and then we merge all of the tooth setups that I showed you in the pre-op phase to the reduced substructure. and we go to mill everything in beautiful, high quality resin materials. And we bring the reduced structure into the mouth. The patient sits in front of some high grade photo equipment, and one by one, we bring all of the aesthetic snap on shells over that reduced framework so that we can get that emotional gut feeling. When we see it, we're going to know, because aesthetics is all about the empirical process where I have to see it to understand if it's going to work. And now, instead of using some wax and modifying with wax, we have all of the shells already prepared, and we just go to change the aesthetic situation by changing each snap-on shell for the next. So I can start to see really what does that triangle between the lateral and canine do to allow light into the smile. What does that point on the lateral incisal edge do to add the little tiny aesthetic finesse that makes a smile so natural? Or what happens if I shift the laterals back suddenly? You have a very soft, natural looking smile. Or if we open up the central incisors, we can get a butterfly effect, something that is very unique. It's not so common, that you wouldn't find necessarily in a restoration. And certainly we did want to get to this slide here where we can show that what we are designing is indeed coming out on the other side. So we can place a lot of faith in these tools to provide us accurate and predictable results that will revolutionize the level of patient care that the laboratory can drive as a service to their doctors. And at the end, the patient gets to go home with this ledger of different options. They can see and show their friends and their family all the different options that the laboratory and the doctor are providing them. And ultimately, we chose the restoration you see at the bottom. Again, this is only in resin at this point. We will copy mill this in zirconia, but you can see the importance of prototyping here. This amazing transition where we have filled out the patient's lips, we have introduced canine guidance, there's balance, there's light coming into the smile. It's more natural, it's more relaxed looking. And at this point, I just want to let everybody know that we are going to launch a brief poll at the end of this presentation. We're almost done. We're also going to answer a couple of questions, but there's one final thing that we wanted to share before we end the meeting. And that is really, how are we going to innovate for the future? What is the future of full prosthetics? Because we've already come a very, very, very long way with digital technology. But Zirkonzahn is committed and dedicated to continuing the progression of digital workflow. And we would like to introduce what we call the modifier software, where we will take the patient situation mounted in the virtual articulator, load an individual occlusal plane called plaster plane, bring in a mounted tooth library, auto-populate the tooth library to the individual occlusal plane, and we have automatic preformed, beautiful gingiva that you can only dream of designing. It takes you hours to design, and now we have it with the click of a button. And we can take this virtual wax up created in a matter of minutes and adapt it to any structure we want. And in a very quick video, you can see how quick this is, really. So we have the patient situation mounted in the articulator. We have the individual occlusal planes. This has not been sped up or anything like this. This is a live recording here. We go to bring the mounted tooth library into the workflow, and we go to load the occlusal plane, and we can adapt those teeth to the individual occlusal plane with a simple click. And now one thing that I think is very beautiful is with another click, we can change the library without changing the positional relationship. And you can choose many different ortho theories from Pound, Giese, Slavicek, whoever you like. And we will also improve on the 3D facial scanning itself by introducing dynamic 3D facial scan animation, where I can, of course, see the patient go from mouth closed all the way to mouth open. And this will be the future of full prosthetics. So with that, I thank you very, very much for your time.